All right, hello everyone, and thank you for joining us today for our Installation Intel webinar, Optimizing Acoustics in HVAC Systems. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go through a few logistics. First and foremost is that many of us are working remotely due to COVID-19 restrictions. So if we run into any technical difficulties that are disruptive to today's presentation, we'll pause the presentation for 5 minutes to see if we can address those difficulties. If we can't correct that within 5 minutes, we will cancel the presentation today and we'll either send you a recording of it or we will reschedule for a future presentation for a future date. And we'll send you an email once that has been rescheduled. Now, if you have any questions throughout today's webinar, you can submit those via the Q&A feature on your screen, and we'll answer them at the end of the presentation. Now, if you don't see Q&A to the right side of your screen, what you can do is you can look down at the bottom right side, and there's a small ellipsis. That's the 3 dots on the very bottom right-hand corner. If you click on that, it's going to open a dialog box that allows you to select on Q&A, and that will open up the dialog box to the right of your screen that actually allows you to submit questions. Please make sure you submit questions to all panelists and not specifically to one person, otherwise it may not get asked at the end. The next thing I want to talk about is that this information is provided it shouldn't be used as a substitute for professional engineering design or documentation that's required by your codes, contracts, or applicable laws. You can refer to our manufacturer's specific application guidelines and instructions and guarantee requirements on all projects. And if you have any questions about that, you can please reach out to us or visit our information on the website. Additionally, we will follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can even use it to ask additional questions you may have about the topic of today's webinar, or you can suggest new topics for future webinars. Now, this is also part of how we deliver the JM experience to you, and the JM experience is based on 4 pillars of the JM culture, and those are listed down there in the bottom left corner: people, passion, perform, and protect. We use webinars like today's webinar to help make sure that we are delivering the best interaction to you, and we use the survey to make sure that interaction is as effective to you as possible. Now, your feedback is a key component to helping us evolve these webinars to better meet your needs. So if you have any questions or comments or suggestions as to how we can better accomplish this, even if you feel like maybe we've missed the mark today, we'd encourage you to fill out the survey, and we'll use your feedback to improve our webinars and provide the information that has the most value to you in the future. Also, we will be sending out a certificate of completion after the webinar is complete. You can use that to submit for professional development hours. We will also send out a recording of the webinar once this webinar has wrapped up here today. And this ensures that you can have the presentation within its full context or share it with your colleagues that you think may find it useful. And we'll send an email to you with both your certificate of completion and the webinar once it's live online. So with that, I'm going to hand it over to our hosts to introduce themselves. That's Brett Graven and Chris Hoying. And we'll go ahead and start with Brett if you want to kick things off.
Thank you, Kim. Yes, my name is Brett Graven. I'm a Market Development Manager for Johns Manville. Live in Madison, Mississippi. I cover Arkansas, Louisiana, Mississippi, and West Tennessee. I've been with the company for 20 years, the first 10 years in our building insulation side, and the last 10 in our performance materials. Thank you.
And hello, everyone. My name is Chris Hoying. I'm the acoustic engineer here at Johns Manville. I operate the Acoustics lab here in Littleton, Colorado within our R&D group. The lab's been here for the last 40 years, 50 years, since probably the early 1970s. And I've personally been working in the field of acoustics and HVAC noise for the better part of a decade now, and that includes shipboard and building applications. And we're going to go ahead and get kicked off since we have quite a bit to cover today. So here's the general agenda of what we'll be covering today. We'll start with some basics, talk a little bit about how noise travels from sources to receivers, and then cover some high-level solutions, how to mitigate these issues, and some of the offerings that may fit the bill for your applications, and cover some minor but critical items. So let's go ahead and dive in and talk about why do we want to control noise. It can be boiled down to 3 general reasons. I'm sure there's more than what we have listed here. Firstly, there may be requirements for legal compliance. This is often associated with schools and hospitals where they have guidelines in which they need to follow. So for hospitals, that would specifically be like FGI, that's the Facility Guidelines Institute. And for schools, it may depend on the school district and their code that they have. But often it's associated to ANSI S1260 or possibly even CHIPS, the Collaborative for High Performance Schools. under a bigger blanket. If you're seeking points for LEED certification, there are specific requirements for noise levels. This can also apply to commercial spaces. Controlling noise, this is not limited to just the loudness of noise, but even discrete tones can affect the ability of people being able to listen and work in a space. And this is incredibly important in schools. Finally, controlling noise equates to better sound quality. So if you have clients looking for a new office, they may be looking at rentals, and if there's a quiet office in comparison to a louder space, that could make or break a deal. On a more residential scale, if you're using proper techniques for dealing with noise, that can equate to better sleep at night and having a space that you're able to enjoy without interruption of audible furnace and air conditioning systems cycling on and off. So these are reasons to be controlling noise, but how is this measured? So noise levels are quantitatively measured in decibels. They are the smallest perceptible change in a level that we as humans are able to detect. That being said, a change in 1 to 2 decibels really isn't noticeable, and getting up to a change of 9 to 10 decibels, things start to sound half as loud or twice as loud. So it's important to note that decibels are a logarithmic scale. They are not linear. So in the top left, you can see a table of some examples of how loud some things may be. So like a whisper at 6 feet is only about 30 decibels. Your typical office that's occupied would be around 60 to 70 decibels. And like a jackhammer would be around 100, 105 decibels. We can interpret noise propagation in a source path receiver model. So sound is generated at a source, travels through some kind of medium. That could be airborne or structure-borne or even liquid-borne, and receives or hits a receiver. So our best option to deal with noise is to fix it at the source. So if you have a noisy fan or a generator, maybe it needs new bearings, or it could be replaced with a quiet air unit, or even relocating it to a location that's further away from the receiver. All these would be your best potential options in terms of dealing with noise. But if you're not able to fix the noise, so at the source, maybe it's a renovation project where you have equipment, you're planning to reuse that, we can't do too much with the source in those cases. So here we can try to reduce the noise along the transmission path, possibly by improving the separation between the equipment and the receivers, or some kind of treatment along those paths. The last and worst option is quieting the noise at the receiver. So this would look like putting your receiver in an enclosure or providing hearing protection. For instance, like a heavy manufacturing plant, you may see signs for hearing protection or double hearing protection. That means they either, in the design or attempts to mitigate the noise, have failed, or currently it's just too expensive for that to be resolved. So they may resort to providing hearing protection. It may seem like a cheap fix on the surface, but we also need to keep in mind this doesn't capture the real cost of dealing with noise, including permanent hearing loss, tinnitus, and other hearing issues, including loss of productivity at times, or even safety. So Acoustics has a huge alphabet soup of acronyms. Some of these you may already be familiar with, and there's definitely more than what I have listed here. You may already be familiar with A weighting, sound pressure level. So that's calculated by taking the individual octave band levels of a measurement at a receiver and adding a weighting to it. So this weighting is directly correlated to how our ears interpret sounds. So lower frequencies are reduced in level, higher frequencies are not as affected as much. These levels are sometimes used to describe a room. I believe LEED is the case where it's described in dBA, and often it's used for setting noise exposure limits, especially with like OSHA, as well as permissible levels that can be received at a property line. Specific to mechanical noise, there are a number of single number ratings that have been created. Each type has their own curve associated to them. So the most popular two, I would say, are NC and RC, noise criterion and room criterion. NC is more commonly used. RC is a little bit newer, and it captures lower frequencies better, which can be found annoying, as well as resulting in vibration issues or rumbling. but unfortunately not a lot of manufacturers are able to measure down to those low frequencies properly, so this can be a hard rating to correctly model as an acoustician. Other ratings can include like NR, noise rating, RC Mark II, balanced noise criteria, NCB, room noise criterion, RNC, speech privacy class, SVC, and probably a slew of others that I'm forgetting. But we'll be mostly covering mechanical noise, so we're not going to get into STC, IIC, and other ratings that are associated with sound isolation. So is there any general correlation between A rating and NC and RC ratings? Somewhat, but since RC and NC ratings are fitted to a curve, they can be considerably different between the two. So the big takeaway is that a single value does not do a good job of capturing what a space may sound like. It really only describes of how loud it can be. So I picked a few spaces that I have taken from a table from the ASHRAE handbook. This is chapter 48. This is the typical standard for developing acoustic models of ductwork, as well as prescribing proper vibration isolation for various mechanical equipment. This shows a couple of spaces that I pulled from that table. They're recommended NC, RC ratings. Acoustic consultants would use a table like this for guidelines for analyzing a space for a system design to see what treatments or equipment may be needed. Ideally, they not only look at the overall rating for a space, but they should ideally take a deeper dive and assess if the sound spectrum that is expected is smooth or not. Regardless of how quiet a space may be, when there are tonal issues, these can be extremely annoying for some occupants. And I do also want to point out NRC ratings, noise reduction coefficients. This is a descriptor of how much sound is being absorbed as it hits material on a scale of 0 to 1, 0 being total reflection and 1 being total absorption, which within HVAC, this comes up in duct lining where sound is traveling down a duct and it will be absorbed as it travels downstream or upstream the duct. Additionally, in mechanical rooms, it can be beneficial to treat the exposed surfaces that could be walls and ceilings, even possibly the sides of equipment, with absorptive material to reduce the amount of buildup in a space, which equates to less sound being able to transmit through walls or floors into adjacent noise-sensitive spaces. Additionally, duct lining is fairly inexpensive and can be used in other applications, including like theaters, where having a black unwrapped butt-faced material can improve the sound quality of a room at a low cost. So hopefully that builds a good base of what we're trying to meet. So let's spend a little time trying to understand where noise comes from and how it can enter noise-sensitive spaces. So we're mostly looking at air handler systems, rooftop units, makeup air units, exhaust fans, etc. in this presentation. But noise can also come from other mechanical equipment, including chillers, pumps, condensing units, swamp coolers, etc. And some of these can be full of tones and very difficult acoustically to deal with, especially at property lines regarding city or county or state noise ordinances. But we're going to focus on air handlers. So they can generate airborne noise, but it's also important to note that this flow of air can also create its own regenerated noise. That could be through undersized ductwork, VAVs, heat pumps, elbows, transitions, junctions, diffusers, and even leaks. You may have selected a quieter unit, but that does not equate automatically to having a quieter system. So this noise can enter into noise-sensitive spaces in a number of ways. I'm going to describe them in a little more detail here in a few minutes as I talk about the potential solution for resolving it. The important thing to note is that resolving one noise path may not reduce the noise level in a room, as all these paths can affect the noise level in a noise-sensitive space. So first we'll talk about the air handler itself. Noise can enter directly into a space, either penetrating through a roof or wall separating the occupied space and where the unit sits, or even exciting the structure that the air handler is sitting or attached to, including through the ductwork and pipes. That energy is transmitted through the ceilings, walls, and floors, so it may affect spaces in a diagonal or even further down into the structure. To deal with this noise path, the most typical options would include increasing the mass of the roof pad or wall, and making sure that it extends far enough out so if there's any diagonal paths that those are accounted for. This can also be beneficial for reducing vibration issues. In all instances, it's critical to be using proper vibration isolation. The ASHRAE Handbook, Chapter 48, has an entire section dedicated to selecting the appropriate mounts. A lot of new air handlers do have internal isolation, and it kind of touches upon that, but it mostly speaks about exterior isolation for the entire unit itself. And as the design allows, units should be placed near or over non-noise sensitive spaces. So you're removing that source, that noise path, so ideally those conference rooms that are on the top level are not being affected by these units. If there's still issues with direct noise and vibrations, a different unit may need to be selected. Next, we have duct breakout. This is caused by large volumes of air, of noise inside the duct escaping out of the duct itself. This is fairly common with main supply and return ducts, especially where rectangular or oval ducts are in an area where they're left exposed with no ceiling. Typical fixes for this can include either using a thicker duct or wrapping the duct in massive duct lining. It's important to note that doing both of those doesn't always equate to better performance. So usually one or the other is the better option. Typically, this is some kind of product that uses a mass load of vinyl with or without a blanket of insulation. If there's space for a silencer further upstream or downstream on returns, this can result in lower levels that are traveling down the duct, resulting in lower levels that are able to break out of the duct. Also, I wanted to mention that using circular ducts are less prone to breakout in comparison to oval and rectangular ducts. But if there's a caveat there, so when those are left unlined, they have less insertion loss in comparison to just rectangular ducts. So they don't absorb as much sound that's traveling down the duct. Next, we have return noise. So this is often due to a large duct coming off your air handler with a short run of duct. Often it's left unlined, and then it opens up into either a ceiling plenum or even in a space without any ceiling at all. Some possible fixes may include adding a silencer to the system or adding thick liner inside the duct. Lagging the outside of the duct will not reduce the levels that are traveling down the duct because the insulation won't be exposed to the airflow. Adding duct length and or relocating the duct to open into an area where it's less noise critical are also possible fixes to deal with this noise. And similar, we have supply noise. So this is noise specifically traveling down the duct. This is caused by noise from the air handler itself or possibly due to regenerated noise to components that are downstream from the air handler. So air handlers are notorious for developing low-frequency noise that's really difficult to mitigate. Using silencers and plenum boxes are pretty good tools to deal with this. Please note that if you put a silencer upstream and then you have VAVs or any kind of transitions that generate noise themselves, your silencer is really not going to be helping with that. So you need to make sure that you're using lining downstream of where those regenerated noise sources may be. Also using flex duct right before the diffuser is pretty good, especially when you have a ceiling plenum because that allows sound to escape out of the duct, but the airflow continues on. If you have exposed structure, those really don't work well because you're still dumping all that noise into the space. And also, I want to talk a little bit about leaks. So leaks would be caused by poor workmanship when construction is done. It may just not be well sealed. So it's important to make sure that when you're doing final checkouts that you're listening for any kind of whistles or anything like that. So that would also not only equate to better efficiency, but also helps acoustically to prevent any kind of tonal issues you may get from leaks. And I also want to talk a little bit about crosstalk. So that's when you have two noise critical spaces and they're connected by a duct. And basically it just can be an acoustic weakness when you may have a solid wall that may be an STC50, but if you have a duct between the two, you may have two patient rooms next to each other, and that could be a HIPAA concern for hospitals, or within conference rooms. If you have HR next to a private office, that would be a major critical issue. So dealing with this, you can either add lining to the ductwork, possibly use flex ducts if there's a ceiling. Ideally, you want to be adding additional length to the duct, and elbows, 2 or more, is preferred. Otherwise, in the design, it's best to have individual VAVs serving noise-critical spaces. That just adds a lot longer path between those spaces. And now I'm going to hand it over to Brett, who's going to talk a little bit more about the solutions that we have.
Thanks, Chris. Appreciate it. So I'll start with the role of insulation and sound control. So as we dive into the solutions that are out there for acoustical insulation, I want to talk a little bit about what makes effective acoustical insulation. The first thing to come in mind is that insulation is not only responsible for absorbing sound, but it also helps reduce the transmission of sound. When you're looking for an insulation to be a quality sound absorber, there are 4 primary characteristics to keep in mind. First and foremost, the thicker the insulation, the better the absorbing sound, of course. Second is density. While density does not impact sound absorption significantly as thickness, it does have an impact on sound control to a degree. The next thing you want to look at is in terms of effective sound absorber is small fibers, diameter, and then cell size. And then finally, you want to have a material that's porous, as the gaps and spaces that are distributed by the fibers or the structure create obstructions for the sound to travel through. This, in turn, helps create a more effective sound absorber, and is why insulation like fiberglass and mineral wool are so effective when it comes to sound absorption. So let's talk a little bit about, let me try to get to the next slide. So rectangular duct insulation solutions. Acoustic insulation sound solutions for rectangular duct insulation. Here are JM's 3 primary ductliners for rectangular ducts. Line Acoustic RC, which the RC stands for reinforced coatings. Line Acoustic RC HP, which the HP stands for high performance. And Line Acoustic R300, which we typically shorten and refer to it as R300 when we're discussing it. The Line Acoustic RC and RC HP are both flexible rolled products, while our R300 is a board insulation. Each of these materials is used to line ducts and can be an effective solution for many of the issues Chris described earlier in his portion of the presentation. Each of these materials can be used in commercial duct applications with airstream speeds that reach 6,000 feet per minute. So let's take a quick look at side-by-side comparisons here. Starting with the Line Acoustic R300, you're looking at a rigid fiberglass board with a glass mat airstream facing. R300 has an NRC value of 0.75 at 1 inch thick with 3 pound density, making it an excellent acoustical insulation. It's ideal for lining plenums and large air distribution ductwork, as well as other unique acoustical control situations that I will address here in a moment. The glass mat facing on R300 is treated with a permacoat, which is JM's EPA-registered antimicrobial coating designed to protect the product from damage. Also, R300 is an excellent solution for applications that may be prone to more physical abuse. Next, we'll look at Line Acoustic RC and RCHP. These products are virtually identical, with the exception that the RCHP is slightly higher density and only comes in 1 inch thick. You can see that at 1 inch, this greater density has marginal positive impact on the NRC value. I'll speak to thickness versus density a little later in the slide, but this increase in NRC value will not be detectable by the human ear. Both of these materials are flexible fiberglass liners, and both have permacoat acrylic coating to protect the product. The distinction you need to make between these two products is that Line Acoustic RC is the workforce liner for Johns Manville. It comes in a variety of thicknesses and R values up to an R12 with an NRC value up to 1.2, which makes it ideal for lining sheet metal ducts. Typically, engineers specify Line Acoustic HP only when there is a density requirement for the duct's insulation called out in the specification. Next, we'll look at exposed acoustical applications. So I did want to point out that our R300 board isn't just used in HVAC acoustical applications. It gets an honorable mention because it is so frequently used in exposed acoustical applications like theaters, sound booths, studios, and large plenums. This picture is a perfect example of Line Acoustic R300 being used in exposed application in a sound studio. We also see R300 used in movie theaters behind curtains where it is an exceptional sound absorbing properties. The point here being is that acoustical insulation doesn't just work in one particular application. Many facility designers translate the product across applications to get the sound controlling performances they need for their specific application. Next, we'll look at spiral duct liner solutions. So with spiral duct solutions available on the market, one thing to keep in mind is rectangular spiral ducts and spiral ducts require different solutions for acoustical control because of the shape of the duct. With a rectangular duct, the material can simply be pinned to the flat surface. With a round surface or spiral duct, it presents its own challenges for insulating. So let's look at the solutions that meet these challenges. The first is Spiral Acoustic Plus. This is considered a single-wall solution. It does not require the inner duct that a double-wall solution would require. It is pre-curved, spiral duct liner, and conforms to the inside of the duct. The next two products are Microlite Standard and Spiral SG are double-wall insulation solutions. Each of these two materials go around an inner duct before being inserted into the outer cast of the metal duct. You can see this in the image on the right under Spiral SG. And then next we'll talk about single-wall Ductliner and Spiral Acoustic Plus. So, a little bit more about why you would choose a single-wall system over a double-wall system first. The advantages of insulating a single-wall system versus a double-wall system are simple as it pertains to the weight and time you would save. When working in the field, the additional weight of the Spiral Acoustic duct might require additional labor for supporting insulation for the installation process with the helping of connecting the pipe. Another advantage of the single wall is that you'll be able to insulate using a higher NRC value when you compare that to the standard double wall, which you can only receive an NRC of 0.65. When you compare a single wall system to that of a double wall, consistency is very important, and that's why using a product like Spiral Acoustic Plus that is pre-curved in the manufacturing facility can be so key for ensuring consistency across varying pieces of insulation. A double wall system will require the proper standoffs, i.e. spacers, to be used inside the duct. If not done correctly, the insulation system could experience compression due to the settling of the inner metal perforated core on the lower insulation, which of course could lead to loss of R value, reduction of NRC, and ultimately could result in condensation buildup on the outer wall of the system, which all of these are not good. Another great takeaway when using Spiral Acoustic Plus versus a standard double wall system is the ability to clean the surface of the liner. Very important. In a double wall system, cleaning out the perforated inner core can be extremely difficult and very time consuming. Henceforth, at Johns Manville, Spiral Acoustic Plus is a great option for large diameter ducts when weight and time become an issue on the job. So let's talk about why Spiral Acoustic Plus and why it is such a great solution for acoustical control. Spiral Acoustic Plus Ductliner is specifically engineered to provide very high acoustical and thermal performance in round air ducts of any size. The way this Ductliner is made is unique. We start with ductboard insulation with a permacoat coat glass matte airstream facing. The board then has grooves called kerfs cut into it in specific measurements. The spacing for these kerfs varies depending on the size of the duct insulation that it will be used in. At 1 inch, Spiral Acoustic Plus offers an excellent NRC value of 0.75, and that increases the thickness as well. Since the insulation is kerfed during the manufacturing process, you can expect that it will offer a consistent thickness and R value throughout. Keep in mind that with Spiral Acoustic Plus, the plus stands for plus permacoat coating. This coating is applied to the airstream surface as well as to the transverse edges of the product. You can touch up any cut edges or gorges that you cut out during installation with Johns Manville's Super Seal, which I think Chris touched on earlier, as well as to ensure to maintain the integrity of the product after installation. Again, our Spiral Acoustic Plus Ductliner is available in 1 inch, 1.5 inch, and 2 inch thickness, with the NRC values of those thicknesses increasing up to 0.95 at 2 inches thick. Additionally, Spiral Acoustic Plus has a great option for very large diameter ducts, 32 inches and up. When ducts of this size are used as part of a double wall system, they can become extremely heavy. Using Spiral Acoustic Plus makes them easy to insulate and significantly lighter than using a double wall system. So next we'll talk about Spiral Acoustic Plus offerings. Spiral Acoustic Plus is uniquely engineered to fit specific duct sizes ranging from our new Vvsd, or very, very small diameter, of 6 to 8 inches to LD, or large diameter of 32 inches and up. For each of these sizes, the kerfs in the Spiral Acoustic are cut at different measurements to ensure a snug fit against the interior wall of duct. The larger the duct size, the greater the variety of thicknesses you can use in the duct, as the smallest duct sizes don't accommodate the insulation thickness because of the lack of space. The greater the thickness, the higher the R value, and the better the acoustical control when necessary. Spiral Acoustic Plus Ductliner has been used in a variety of stadiums across the U.S. with ductwork that exceeds 96 inches in size. So I would suggest the next time you're watching football games, whether it be college or pro, specifically pro, take a look at the duct size in the top of the stadium and just get an idea of how large those ducts really are. So why Vvsd? Historically, Spiral Acoustic Plus has been the primary use in ducts with diameter of 10 inch or larger, and occasionally used in smaller ducts. That being said, it hasn't been easy on the fabrication shops as fitting a material designed for 10-inch duct into 6 to 8 inch duct. Naturally, it's going to be difficult. So the pre-cut kerfs in the Vvsd, very small diameter Spiral Acoustic Plus, were not spaced to fit 6 to 8 inch duct, or what we would consider now our Vvsd, or very small diameter ducts. In order to use Vvsd, very small diameter, Spiral Acoustic Plus on a Vvsd duct, most shops were choosing to recut the insulation to make it fit better. This is incredibly time-consuming and was taking shops hours, if not days, to finish out just single projects. Naturally, in a fabrication shop where efficiency and optimization are key, fabricating insulation is not an effective use of the shop's time. I think we would all agree there. To remedy this, JM recently released Vvsd Spiral Acoustic Plus. This new product is the only pre-curved spiral ductliner on the market and has been engineered specifically for Vvsd ducts. The Vvsd insulation is only offered in 1-inch thickness with an NRC value of 0.75. It is not offered in greater thicknesses due to the lack of size inside the duct itself. Again, you couldn't fit 2-inch Vvsd inside there. You would have zero space for airstream. So the next slide, we'll talk about double wall spiral ductliner. While a single wall system does offer benefits over double wall systems in many circumstances, many specifications still call for double wall systems. In this type of system, the insulation and the liner and the inner duct wall work together to offer an acoustical control. The insulation itself offers an NRC of 0.65. When the interior duct is perforated, it also contributes to an improved acoustical control. As I said before, with this type of insulation, it is critical to use spacers between the liner and the duct, specifically the outer duct, so that the insulation does not become compressed, reducing the R value and the acoustical performance that you're trying to achieve. So we'll look at Microlite Standard Utility Wrap and Spiral SG are both insulation materials used in this application. Spiral SG is more common and it was designed specifically for double wall applications, while Microlite Standard Utility Wrap is used simply because it's higher adaptability for materials that can be used in a variety of applications. It's also worth mentioning that in the field, installing Spiral Acoustic Plus duct is much easier than field installing a double wall system because of the weight difference and because you don't have to connect the two pieces of metal pipe, the inner and outer sleeve that you would have with a double wall system. So next, let's look at closed cell elastomeric foam, or duct liner. One thing I did want to touch on that in the field I have seen many people choose to use a closed cell elastomeric rubber duct liner in acoustical applications. It's important to note that while closed cell elastomeric rubber does offer some acoustical control, the insulation lacks some of the material properties that help create an excellent acoustical insulation, namely porosity. When you compare the NRC value of 1 inch of rubber to 1 inch of fiberglass, you can see that there is distinct difference in acoustical performance, with the rubber coming in at an NRC of 0.4 to 0.55, depending on the brand, of course, and fiberglass coming in at 0.7 to 0.75. Naturally, as Chris mentioned earlier, in settings like schools where it is crucial for children to maintain their focus, selecting the better acoustical insulation can be paramount to creating an effective environment for children to learn. So if acoustical control is your primary aim, an insulation like closed cell elastomeric rubber is not going to give you the best solution. Additionally, it's typically more expensive than fiberglass. So now we're going to touch base on the importance of density. Speaking of the characteristics that make good acoustical insulation, let's talk about density. We occasionally see ductliner insulation specifications that call out ductliner density over other physical characteristics. I see this a lot in my area. It's important to note that since 1986, the ductliner specification for the industry is ASTM C1071-12. Standard specification for fibrous glass duct lining insulation, which is basically thermal and sound-absorbing materials, has allowed specifiers to select materials based on performance rather than on density. This specification calls out fiberglass duct liners to meet certain performance requirements and has replaced the old government federal specification of HH-I-545, which includes insulation, blankets, thermal, mineral fiber, and industrial-type insulations, which basically specified material to be of density. They're looking for density there in that specification. These old specifications are outdated as adding density typically only adds glass to the actual manufacturing process without substantially improving the product's performance. Ultimately, this typically increases material costs without addressing or improving acoustical or thermal performances that are required. So next, we'll look at acoustical performances, density versus thickness. When we look at how density impacts acoustical control, it's important to note that both thickness and density can improve sound absorption. However, thickness will have a far greater impact on sound absorption than density will. When you look at these two graphs, you can see the impact of density on sound absorption on the left. The density is identified in the numbers in the middle of the graph, ranging from 0.5 PCS on the blue bar and on the right to 10.0 PCS on the red bar. The sound absorption coefficient is on the y-axis, ranging from 0 to 1, and you can see that every density absorption coefficient starts at 0 with varying degrees of effectiveness depending on the frequency. In contrast, the thickness chart on the right has thickness ranging from 1/2 inch to 3 inch, and the sound absorption coefficient automatically starts higher with 2 inch to 3 inch material. The story that both of these graphs tell, while both thicknesses and density impact acoustical performance, thickness will have a far greater impact than density will. This is perhaps the most obvious when we compare Line Acoustic RC to our Line Acoustic RC HP, again the HP high performance. RC HP has a greater density than Line Acoustic RC. However, the greater the density only leads to an increase of 0.05 increase in the NRC value. This marginal increase would not be audible by the human ear. However, when we look at the different thicknesses of Line Acoustic RC, it's obvious that the thickness plays a much more important, impactful role in influencing sound absorption performance, where at 1 inch, the NRC is 0.7, and at 3 inches, the NRC is 1.05. So next, we'll look at improving specifications. So what does all of this mean for a specification writer, a mechanical contractor, or an installer, a commercial installer? What you need to keep in mind is that specifying HVAC insulation materials based on density alone adds glass to the manufacturing process, also increasing cost of the material without adding significant improvement for added cost. As you review and update your specifications, you can create a more effective specification by focusing on thickness over density. And then next, we're going to talk a little bit about liner versus wrap. So one thing that you may have noticed missing from this presentation is any discussion about duct wrap. The reason for that is because duct wrap is not an effective acoustical insulation. Let's take a quick look at the difference between Duckliner and duct wrap to help establish where each of these can be used to its greatest effectiveness. Duckliner benefits here. I'll just touch base on this lightly. As we've spent the majority of the presentation today talking about Duckliner, there are two primary benefits to lining duct: thermal control and acoustical control. This can allow the system designer to improve the efficiency and the acoustical performance of the duct while maintaining the aesthetics of the metal duct. Additionally, Johns Manville Duckliner are all coated with a permacoat coating to protect the product from mold and mildew growth. The duct wrap benefits. When we look at duct wrap, the purpose for the insulation is different. Designers should consider using duct wrap insulation when acoustics are not a priority. Let me reiterate that, when acoustics are not a priority. Duct wrap offers an excellent thermal control, and the facing can help control the condensation. And JM even offers our new black and white face duct wrap insulation that can be used as a design element, but duct wrap should not be used in applications where acoustical control is a requirement. And then we'll look at liner versus wrap. So as you're looking for an acoustical insulation solution for your applications, you should keep in mind, or you should keep your focus on Duckliner for insulation of double wall systems, as these insulation materials are designed for two things, thermal and acoustical control, while duct wrap is designed for condensation and thermal control. At this point, I will turn the presentation back over to Kim and let her take over from there.
All right, thank you so much, Brett. So we've had a lot of good questions come in. Before we dive into questions, I do want to go over a couple of additional resources that we have and hit on the certificate of completion once more. So first and foremost is the source, and this is basically our online resource library where we keep all of our technical webinar recordings, we keep specification information, you have access to our most latest blogs, you can get descriptions of each of our products, comparing them side by side, access to tools like the JM Smart Binder app that you can download to your phone, and then online training options as well. So this is a great resource for anybody who's looking for more information about HVAC applications across the board. So this doesn't just apply to acoustics, but anything having to do with HVAC systems. So the next thing I'm going to talk about is our certificate of completion. Actually, before I dive into that, if you do check your chat box, you should have just received a link from Dana Martin directly to the source if you have any interest in checking that out today. The certificate of completion, everybody who attended here today will receive a certificate. So that will be delivered to your inbox by next Monday. And if you don't receive your certificate, please reach out to us. We'll be happy to make sure that you do get that. So with that, we're going to start with some questions. I do want to introduce, joining us on the call, we have Brennan Hall, our Senior HVAC Product Manager, and John Elverum, one of our Senior Technical Engineers at JM. They're both here to help answer any questions that we might not be able to tackle with just Chris and Brett. So with that, we're going to dive into the first question, which is actually one I'm going to address, and that is, please address any IAQ concerns of insulation installed inside the ducts. And then there was a subsequent question later submitted about fibers entering the airstream, and that there are some, let's see if I can find the question here. Anyway, the question is, can I use fiberglass Duckliner basically inside the duct because of the risk of fibers entering the airstream? So there are a couple different facets about this. The first thing I want to do is encourage you guys to visit the source and watch our webinar on fiberglass health and safety. So the first thing to point out is that fiberglass has been tested and studied for decades, and it is not a known carcinogen. It's not considered to be a suspected carcinogen. And the reason for that is because all of the glass fibers used in Johns Manville's HVAC Ductliner and duct insulation are considered biosoluble. So that means that they are able to be dissolved in the human body in a very short period of time before, without causing any sort of damage to the lung or surrounding tissue. What you need to know about fiber shedding in the airstream or Ductliner erosion. So part of this testing was exploring whether or not the materials shed these fibers into the airstream and subsequently into the living spaces or working spaces for people who are working with fiberglass. So there were two studies done. One is an occupational exposure hazard study to determine if people who are working with fiberglass fibers are being exposed to massive amounts of fibers. And then the other one was in office spaces and apartment buildings. Are these places where, just normal people, not even people who are working with fiberglass, are being exposed to fibers? So in the occupational exposures, they have more than 18,000 data points. And with the exception of when blowing wool is being installed, so in an attic, and fibers are literally being blown into the air, you're getting exposure levels that are well below the OSHA NEMA voluntary permissible exposure limit of one fiber per cubic centimeter. So on average, you're looking at, for people who are specifically working with product, you're looking at below 0.25 fibers per cubic centimeter, and all of the studies have shown that you're below 0.4 fibers per cubic centimeter, with the exception of those blowing wool applications. Now, when we look at residential and office spaces, you definitely have concerns because you don't want people in buildings being exposed to anything that could be potentially hazardous to them. So one of the studies they did is they tested, they took air samples in 205 buildings, and they found that overall, just fibers in general, not insulation glass fibers, but organic fibers, all fibers are very low in indoor spaces at 0.008 fibers per cubic centimeter with a maximum of 0.029. Now that's all fibers, including organic like curtains, drapes, hair, etc. What we found is that 90% of those fibers are organic in nature. And when we look at the inorganic fibers, we find that less than 0.001 fiber per cubic centimeter were present, and that were only present in 2 of the 205 samples. So that's a lot of information I got just covering this one question, but I did want to be very thorough in this. And the reason for that is because there's a lot of questions about, oh, fiber-free is bad and fiber shedding is bad, but the data does not show that fibers are actually being exposed or even torn off of the insulation in Duckliner applications and shed into the airstream. And then when we look at the resiliency of the product itself, you know, all of our Duckliner insulations that we talked about today are tested to UL standards, and that means that they have to face hurricane force winds. So they are tested at 6,000 feet per minute. That means when they're in a UL test, they have to go up to 1.5 times the testing, or 1.5 times the speed that they're rated to. So that means we're looking at 15,000 feet per minute, which is hurricane force winds. And in those testing, they can't experience any sort of delamination, erosion, any sort of destruction as they're being tested. So when you're looking at whether or not fibers are going to impact the indoor air quality, that's simply not something that's negatively happening there. What's happening is that the fibers are helping contribute to better acoustical control, better thermal control, and not damaging or hindering the indoor air quality. So it's a very long explanation. You should have a link to that webinar in your chat box. The next question I have is this one is for Chris, and I'd like you to go ahead and talk about it. It says, you may already be planning to speak to this, but for a transfer duct application on our mechanical details, call for 1 inch of acoustical lining. But I'm curious how the acoustical performance compares between fibrous lining and a closed foam type lining.
Yeah, and I think Brett also touched upon about the performance difference that you do see between the two materials. But basically, fiberglass can't be matched in comparison to closed-cell elastomeric. But obviously, there may be limitations where projects say they don't want to see fiberglass lining. And in instances where you have like transitions, there may be some difference in performance depending on the size and the shape of the ductwork, but fiberglass is likely to outperform closed cell acoustically.
All right, thank you. The next question we have is, what are the detrimental effects to acoustical insulation due to water ingress to the HVAC system, and can wet acoustical insulation be reused? Brennan, if you could go ahead and take that one, please.
Sure, good question. So once insulation gets wet, or once fiberglass insulation gets wet for sure, you're going to want to replace it. You don't want to leave it in there. Water is not a friend of fiberglass, especially when it gets very, very wet. So it reduces the thermals. It's going to cause just a mess in your ductwork. You want to get rid of anything that's wet that is in your ductwork and replace that insulation, fiberglass insulation in particular, if it's getting wet. You ideally don't want to have that much water in your system if you can avoid it, and it is going to make some impact to the product itself. And we would recommend removing anything that's very, very wet in your system.
Great, thank you. The next question we have is, I'm interested in acoustic insulation for really small 4-inch ventilation ducts and fittings. Is insulated flex duct the best option? Brett, can you speak to that? And if you're speaking, Brett, you are still muted.
Sorry. So yes, possibly it would depend on the application, but please keep in mind that it's critical to the size of the duct appropriately so that the airflow and the velocity is kept to a minimum. I would suggest ASHRAE, Chapter 48, Table 8, has more detail on the recommendation of airflow velocities. QuietFlex may have some 4-inch options available, but again, you would just want to reach out and look at that.
All right, thank you. Is there anyone else who'd like to add to that? Brennan, did you have anything?
No, I think he covered that one fine. I'm okay with that. I don't have anything to add there.
All right, thank you. So the next question is for you, Brennan, and that is, what part can pressure-sensitive tapes play in helping to achieve the goal of optimizing HVAC acoustics?
Sure. So I would say, relative to the question, if you're referencing pressure-sensitive adhesive, that probably is referencing to a ductboard type system, because you're going to use more than likely a pressure-sensitive UL 181 rated tape for the ductboard application, which is required for sealing the system. Because the ductboard, it turns itself into a duct. That closure system is extremely important, coupled with the outward clenching staples as you join that seam or the transverse joints with the ductwork. So you're definitely going to make sure using that pressure-sensitive adhesive on a ductboard application is really critical to the actual installation of it. So it's not going to necessarily provide any acoustical benefit from the pressure-sensitive tape per se, but it is required for a ductboard installation itself.
All right, thank you. The next question we have is for, I'm going to go ahead, sorry, I'm reading the question. So the next question we have is, we fabricate duct and use large quantities of insulation. Is there any research going on repurposing or recycling scrap insulation? And Brennan, if you could speak to that one as well.
Sure. So, there's always things that we're trying to do to find better ways to reduce scrap or reduce recycle insulation within the industry, right? So from the manufacturing side, there's lots of ways that we can reintroduce scrap back into our, whether it be edge trim or things like that. That's just from our manufacturing process itself. So we do have things internally at our plant where we can refeed different things back into the process to do it. One of the big problems or issues with your products once they get into the market is once you put on, whether it be an FSK facing or whether it be a black matte facing or any type of facings, those things have to all be separated out and completely removed apart from the insulation. Those things really can't be reused. We have to remove them even if we're going to reintroduce something in our process in the refeed systems on our manufacturing line. So that makes it very difficult for things to be reused. We're always trying to find different things, ways to reduce scrap, at least with the fiberglass, but we have not come up with a great solution as of right now. One of the things that we did just recently do was we had some customer feedback around our wood pallets for our ductboard products or any of our board products where the 4x10 or 4x8 pallets are really not useful. They're hard to get rid of. They're big and bulky to move around. So we introduced what we call our E3 pallet, and that's helped address some of the scrap that's been left over or wasted from our process as our customers get it, but that's helping with the wood and the pallets that are left over. But from the fiberglass side, there's not a whole lot that we have right now. We're trying to find things. There are some projects that are open around it, but we don't have anything currently right now. So, we don't have a great solution right now, unfortunately.
All right. Thank you, Brennan. I do notice we're coming up to the top of the hour. We still have a lot of questions in the queue, so we will go up to 15 minutes after the webinar. Anything we don't get to today, we will answer privately in an email after the webinar has concluded. So just so everybody's clear, if your questions don't get answered, we will send you an email separately. The next question is for you, Chris, and that is, what guidelines can be applied to minimize audio transmission through ductwork? For example, low-frequency output from a subwoofer in a theater or media room can travel through ductwork into adjacent areas. What best practices can be employed to avoid transmission?
Yes, and this is kind of associated to the crosstalk slide. So adding elbows and length of duct that are lined, ideally as thick as you can go, 2 inches or more if you can, should ideally not be shared between noise-critical spaces. So they should be served through individual heat pumps, VAVs, etc. As more makeup air units are being used in large apartment buildings and condos, ductwork is often unlined and ties units together. So that's why you're hearing the dog barking a few neighbors down. This isn't ideal, and especially with low frequency, that can be very difficult to deal with. And alternatively, you could probably go to a silencer, which would definitely help with that low frequency spectrum, but it's difficult to deal with.
All right. Thank you, Chris. The next question is for you, John. So the question is, what should architects look for when we're reviewing the mechanical engineer's drawings?
Just some things to consider are the product selections current? Are they 20-year-old specs and they're asking for outdated or no longer produced materials? They should look for space constraints. Can the material fit the space that there's to be installed in? And are they code compliant?
All right, thank you. The next question, Chris, I'm going to send this one to you, and that is, if the air handling unit discharge velocity is high, and I don't want duct lining for the first 10 to 20 feet, do you recommend a perforated metal faced lining?
Yeah, I think that would be a decent means of trying to deal with that. You may see a slight difference in performance in comparison to just having fiberglass in that duct, but yeah, I think using a double wall perforated interior wall would be pretty ideal.
All right, thank you. I did want to cover one thing really quickly. I know that Brett referenced an R12 insulation. There was some misconception about whether that was at 1 inch. We do not have an R12 fiberglass at 1 inch. We only have an R12 fiberglass at 3 inches, and that's in line acoustic. So I want to make sure everybody's clear on that before anybody drops off at 1 o'clock. All right, the next question we have is also for you, Chris, and that is, which has the higher sound absorption for density, mineral wool or fiberglass?
Oh, that's a good question. So it's actually a ratio between airflow resistivity and density that equates to a good absorbing product. And so when you compare mineral wool versus fiberglass, they both have that same relative ratio. So they actually perform pretty comparable. You may see a little bit of difference in one octave band in comparison to another, but overall they're pretty comparable in performance.
All right, thank you. Brett, the next question is for you, and it is, how do those round transitions work? They're talking about the Spiroacoustic fittings. Are those custom orders or tapered shapes?
So those would be the custom fittings that you would need there. Those can be they can be fabricated in individual shops, or if you can find somebody in your market that makes those or has access to our Spiroacoustic Plus, they can make them for you. But typically those would be handmade in the shops.
All right, thank you. The next question is also for you, Brett, and that is, if the Vvsd is slid into the duct, what is the maximum length they can work with in the shop or on site?
That's a good question. That really, it depends on the actual contractor itself and how long they're comfortable with fabricating the duct. I've seen customers here in my area use ductwork as long as 10 feet, and they'll cut the material and slide it in, and then cut another piece, slide it in. So it depends on the contractor and what they're comfortable with handling inside their shop, and then vice versa, getting it out to the job site and what they can physically handle on a job site if they're on a scissor lift and trying to get it up 20, 30 feet in the air. You may want to be careful in not overextending yourself with say a 30-foot duct up there. You may want to regulate that back to maybe 10, 12, 16 feet, something that you can manage.
All right, thank you. We did have one request for the ASTM Duckliner standard number. Brennan or John, can you supply that offhand? And I know, Brett, it's in your notes, so.
I'd say ASTM C1071 for the liners.
All right, perfect, thank you. The next question we have is, what product would you recommend for a direct evaporative DOAS unit, an application where acoustics and thermal control are required? Brett, maybe you could speak to that first and then hand it off to Brennan.
So I would suggest there Acoustic RC. That would be the first product that I would go to. I'd probably want to talk with the contractor or the engineer and learn a little bit more about the design, but first and foremost, I would look at our Line Acoustic RC as the product to go to. Brennan?
Yeah, I would say just looking at the question and reading it too. So there's another portion of our business, because you're looking at the evaporative unit itself, right? Like the actual equipment is what it sounds like the way the question was posed, Tim. We do have a very robust OEM division that does a lot of specialty applications with different solutions for the units themselves. So our business is split up in the performance material sides, where we have an air handling division, which is kind of from the unit down through the ductwork. We have the mechanical division that handles our pipe type installations, and we have an OEM division that also handles all of our what you would think of as your equipment, air conditioning equipment, right? Solutions that go into large air conditioning equipment manufacturers or OEM type units, things like that. So that may be something too that would be an OEM application that our OEM division could look at too, and probably provide something more specific to that particular application too. Just taking that question from another point of view versus the way Brett answered it, I guess.
All right. Thank you so much, Brennan. So the next question we have, John, I'll go ahead and pass this one off to you, and that is, do you have any suggestions or rules of thumb to use with using Duckliner in an air handling unit application that has steam humidification?
The main thing is you don't want the steam to directly impinge on the Duckliner so that it's going to condense and turn into liquid moisture. So a lot of times what they'll do is there'll be a separation where they can generate the steam so that it's higher in humidity going downstream in the duct, but it isn't going to be in a condition where it's going to condense on like the sides and the walls of the duct and create pockets of standing water.
All right. Thank you very much. The next question we have is for Brennan and Brett, and I'm not sure we'll have an answer for this, but we'll leave it to you to see. Another issue we have with Duckliner is the installing contractor's quality control. Not sealing seams and joints due to negligence obviously isn't yours to control, but what can you do to instruct installers to improve their quality control?
So, sure, I can take that question. I'll start on that. So it's a good question, right? I think all installation of ductwork, right? Like the quality of the fabrication, the way that you're trained to do it. There's a SMACNA, the Sheet Metal and Air Conditioning National Association, as well as NAMA, has installation standards for not only the fiberglass but how to put a duct system together, how to properly construct a sheet metal duct system from A to Z, a wealth of information, a wealth of knowledge. I think a couple things there. We do different things throughout the year. We do a lot of webinar trainings. We do trainings within our facility where we bring not only our customers in, but contractors can come into our facility, and we do an on-site kind of day and a half training around fiberglass and talking about, we call it our product information workshop, where we have a chance to talk about some of these type of things with whether it be a distributor, sales rep, or contractors, whatnot. We usually open that up. Obviously, this year with COVID, we didn't get to do that as our in-person event, but there's things that we can do and talk about that. You always have to be careful. You're walking a slippery slope, walking in and telling a contractor how to do their job, right? That's not an easy conversation to have, and I think the more you can educate yourself on how ductwork is supposed to be properly done, right? Inspectors have to make sure they're looking for the right things, whether it be an owner's representative that's on the job site looking through things. I know there's a lot of conversation around. I think there's like a commissioned, the name of the title of that person is evading me at the moment, but people that go in and kind of look through and review that type of work, right? And a lot of it comes down to the contractor's integrity. I would say you're going to get what you pay for. If you're looking for the cheapest guy on the block or the cheapest installation that's out there, you're going to get what you pay for. If you want to pay for a Toyota or, not saying that Toyota is bad, but if you want to pay for a lesser automobile versus a more expensive high-end automobile, you're going to get that contractor's knowledge, know-how, expertise in installation, right? There's a lot of contractors that do it very, very well. I would say the majority of them do, but there are that group of guys that don't do it right, and they give the rest of the industry a bad name, and it makes things go in the installation process not as well. So we try to do some different training things. It's a lot about education as much as we can with these type of webinars, answering these kind of questions, giving people the right tools, the right access, being present at industry events, making sure contractors understand things that we hear, right? I do a lot of things with SMACNA, and I tell their contractors regularly, hey, this is things that I've heard, or this is things that I shared. We have a great relationship with the technical department there. I know they're doing a lot of things to try to make sure that their contractors do things well. So, it's a lot of just being educated and understanding what to do, and subtly letting them know that, hey, I want to have this changed, or I want to have this reviewed without, stepping over and out of your bounds, right? So it's all education. It's all making sure that it's done the right way.
All right. Thank you so much, Brennan. So that actually wraps up all the questions we've had today. There were a couple questions we didn't get to, but we'll answer privately offline. Thank you all for joining us today. We hope you found this webinar helpful and informative, and we hope you take care of yourself the rest of this week and have a safe and happy holidays.